Hi, hello friends. Welcome to Indian Tech Guru for you. In this video, let us learn about 0 by 1 knapsack problem. So here we are going to solve this problem using dynamic programming approach. First of all, what is meant by 0 by 1 knapsack problem? A knapsack is nothing but like a bag in which we can place the items, or we can consider like a box in which we can place the items. So here 0 by 1 knapsack means either we can insert the complete item or we may discard the complete item. We cannot actually insert a fraction of the item. So that is represented by 0 by 1 knapsack. Here, what data is given to solve this problem? To solve this problem, we will be given the capacity of the knapsack, capacity of knapsack, and then we'll be given the number of items available, and then we'll be given with the profits of each item, and finally we'll be given with the weights of each item. So this data will be given. So based on this data, we need to determine the maximum profit that we can get, and whether a particular item is inserted or not inserted inside of the knapsack. So the capacity of the knapsack, which is represented by M, number of items represented by N, profit of each item represented by Pi, weights of each item is represented by Wi. Let us assume M is equal to 8 and number of items are 4 and Pi values are Pi equal to 1, 2, 5, 6. What does it mean? P1, P2, P3, and P4. Next, W values are 2, 3, 4, and 5, which is represented by W1, W2, W3, and W4. So these are the values given. Now what we need to find out? We need to find out the Xi values. Xi means X1, X2, X3, and X4. So which represents whether the item is included or not included. If the item is completely inserted into the knapsack, then the value of X will be 1, otherwise the value will be 0. We cannot insert fraction of the knapsack, fraction of the item, such as 2 by 5th part, 1 by 4th part. It is not possible in case of the 0 by 1 knapsack. However, it is possible in fractional knapsack. Now let us try to solve this problem. To solve this problem, first of all, we need to draw a T table. A T table actually contains the weights as well as the profits. So here, so what could be the number of rows and number of columns? The number of rows are equal to n plus 1. N plus 1 means n value here is 4. So totally there must be 5 rows. 1, 2, 3, 4, and 5. Totally 5 rows we need to take. So name it as 0, 1, 2, 3, 4. That is, we need to consider the 0 object also. 0 object, 1 object, 2 object, 3 object, 4 object. So here it represents the objects are items. Objects are items. Here it represents the weights. So weights, how to consider weights is we need to consider m plus 1 columns. M plus 1 columns. That is totally 9 columns we need to consider. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Total 9 columns. So these 9 columns represent the weights. So 0 weight, 1 weight, 2, 3, 4, 5, 6, 7, 8. So from 0 to 8. So what does it mean is whatever the box, whatever the knapsack we are considering, we are assuming that this particular knapsack can be divided into either blocks of 1, either blocks of size 1, or blocks of 2, or blocks of size 3, 4, 5, 6, 7, and 8. So that is the internal meaning. Now, what are the PI and WI values? PI values are 1, 2, 5, 6, and WI values are 2, 3, 4, and 5. Now we need to fill the values for this particular table. The values for this particular table are profits. Profits. Okay. We need to fill with the profit values. So based on what criteria we need to fill the profit values. So for object 0, actually there is no object 0. That's why all the profits for object 0 will be zeros. Similarly, whenever the weight is 0, we cannot insert any of the item. That's why for all items, the values are zeros. Okay. So that is the first row as well as the first column are all zeros. Now let us try to fill the row with item number 1. Item number 1 row must be filled. So whenever we consider item number 1 row, we need to consider the weight of item number 1. So this is I1, I2, I3, I4. I represents item. So we need to consider item 1. Item 1's weight is 2. So I can fill this particular item with weight 2 directly in a box which is provided inside of the knapsack with a box of 2, weight of 2. Okay, that block size is 2. Here the weight of item 1 is 2. Now directly I can fill this particular item number 1 into this particular box. Then what will be profit? The profit will be 1. So I need to fill with the profits. So I'm going to fill with the value 1. So as the item weight is 2, shall I fill it with a box of size 3? Yes, I can fill because 3 is greater than 2. So that's why here also the value will be 1. For all the remaining columns also the values will be 1s. And as I could not fill the item with weight 2 into a block of size 1, this value will be 0. Like this, we are going to fill the item number 1 values. Next, coming to item number 2, whenever we need to consider item number 2, either we can consider item number 2 itself, and we need to consider the combination of item number 1 as well as item number 2. So if you consider item number 2 itself, then the weight of item number 2 is 3. That's why we can fill this particular item number 3 in a block of size 3. Whenever I fill like this, then what will be the profit? Profit is 2. So here the profit will be 2. Similarly, I can fill both item number 1 as well as item number 2 at the same time. Then the weight will be 5. So whenever the weight is 5, I can fill this particular both the items in a block of 5. So then what will be the profit? 1 plus 2. the profit will be 3. As I could fill both of these items in block number 5, I could fill in block number 6, block number 7, block number 8 also, so that the profits will be same for block number 5, 6, 7 and 8. Similarly, if I could fill item number 2 in a block 3, then I could fill in block 4 also. So that's why its profit will also be 2. So the remaining values will be same, because we could not actually fill an item with weight 2 in block size 2, in weight 3 with in block of 2, in weight 3 in block of 1. So that's why remaining values will be same. Okay, so just remember that after filling these values, whatever the left side values, they will be same. Why they will be same? Because we cannot fill item number 2 in block number 2 because its weight is 3. Here the block size is 2 only. So that's why we cannot fill. However, we can fill item number 1, which is having weight 2. That's why the value is 1. So like this we need to assume. Next, coming to the third item or third object. The third object we need to consider individually as well as in groups. So first let us consider individually. The weight of third object is 4. So we can directly fill this particular third object into a block of size 4. Then the profit will be 5. So fill with the value 5 here. And similarly we need to take the combination also, all the previous items. So if I take the combination of 4 plus 3, these two items, if I want to fill at the same time, then 4 plus 3 is 7. There is a block available with the value 7. Then we can insert these two items, item number 2 and item number 3, at the same time in block number 7. Then what will be the profit? 5 plus 2, 7 will be profit. So fill the value with 7. So now let me consider item number 3 and item number 1. Then what will be the weight? 4 plus 2. 4 plus 2 is 6. So there is a block available with value 6. That's why I can directly insert item number 1 and item number 3 at the same time. If I insert like that, then what will be the profits? Profit of item number 1 is 1. Profit of item number 3 is 5. 1 plus 5, 6. So this particular value will be 6. Now, is there any other combination? There is no other combination. So that's why we need to fill the remaining values. If I could fill item number 2 and item number 3 in block size 7, I could also fill in block number 8. If I could fill item number 3 in block 4, I could also fill in block 5. So the value will be 5. So remaining left side values will be filled as it is. Next, coming to the last item. So what is the weight of last item? The weight of last item is 5. So there is a block of size 5. I can directly fill in this particular block. Then what is the profit? Profit is 6. So block number 5, profit is 6. 6 will come here. And now consider the combinations. If I consider item number 4 and item number 3 combination, then what will be the total weight? Total weight is 5 plus 4, 9. But there is no such block available in the knapsack. So discard it. Next, consider item number 4 and item number 2. So what is the value? 5 plus 3, 8. 8 is the value. Weight is 8. And there is a block available with the weight 8. So now what I need to do? I need to insert item number 1 and item number 4 at the same time. So if item number 2 and item number 4 at the same time. If I insert item number 4 and item number 2 at the same time, Then I need to consider the profits of item number 2 and item number 4. That is 2 plus 6, that is nothing but 8. So I need to insert in the block 8, the profit will be 8. Now I need to consider item number 4 and item number 1. So 5 plus 2, the weight is 7. There is a block with block size with 7. So I could fill item number 1 and item number 4 in the block of 7 directly. Then the profit will be 1 plus 6, 7. Now, how to fill the remaining fields? As I could fill the item number 5, the item number 4 in the block of 5, I could also fill in the block of 6. So the value will be, the profit will be same. And as far as the remaining values are concerned, fill it as it is, as in the above row. Okay. So like this, we have successfully filled all of the values, all of the profit values in the T table. Now the T table is ready. Based on the T table, what we need to find? Based on the T table, we need to find the x1, x2, x3, x4 values, which determines that whether the item is completely inserted into the knapsack or not inserted into the knapsack. So for that purpose, let us first consider the row number 4. Row number 4, which represents the fourth item. Row number 4 represents fourth item. So here in the fourth item, what is the maximum profit we are going to get? 8 is the maximum profit we are going to get. So because the maximum profit we are going to get is 8, we need to check whether this maximum profit we can get using the third item or not, item number 3 or not. So however, there is no such a value in item number 3. So that means that we are going to get the maximum profit 8 using item number 4. So that's why item number 4 is included, and its x4 value is 1. So after that, after inserting item number 4, what is the profit of item number 4? What is the profit of item number 4? 6 is the profit. Already, what is the maximum profit we got? 8. So what is the remaining profit? 8 minus 6 is equal to 2. 2 is the remaining profit. 2 is the remaining profit. Now go to item number 3. Go to item number 3 and see whether profit 2 is there or not. Profit 2 is there in the item number 3, but we need to check whether item number 2 provides the same profit. Yes, in case of item number 2 also, it is going to provide the same profit. So that's why we should not consider item number 3, discard item number 3, because item number 2 is providing the same profit. Now compare item number 2 and item number 1. Item number 2 is providing the profit 2, and check whether item number 1 provides the profit 2 or not. Item number 1 is not providing the profit 2. Now you need to include item number 2. What does it mean? We are inserting item number 2 into the knapsack. So that's why x2 value will be 1. x3 we have discarded. So now item number 2, profit is 2. 2 minus 2, that is equal to 0. Now consider 0. Consider 0 profit. 0 profit is available in item number 1. And now check whether this 0 profit is available in item number 0 or not. Item number 0 also, this 0 profit is available. So that's why discard item number 1. That is x1 value will be 0. So like this, we need to solve this problem. Now what are the values of x1, x2, x3, x4? 0, 1, 0, 1. What does it mean? we have completely inserted item number 2 and item number 4 inside of the knapsack, and we have completely discarded item number 1 and item number 3 inside of the knapsack. So now what is the profit we are going to get? The formula to calculate the profit we are going to get is sigma I is equal to 1 to n pi into xi. So pi into xi, because x1 and x3 are zeros, I need not to consider x1 and x3. So x2 into p2 plus x4 into p4. So that is p2 value is item 2 profit is 2, item 4 profit is 6. So total profit we are going to get is 8. Like this, we are going to calculate the maximum profit we are going to get by inserting the items inside of the knapsack. Totally, how much weight we have inserted for item number 2? What is the weight? 3 is the weight. For item number 4, the weight is 5. 3 plus 5. Totally 8 we have inserted. So that is the maximum size of the knapsack. So like this, we can solve the 0 by 1 knapsack problem using the dynamic programming approach. Hope you understand the logic. Still, if you have any doubts, you can ask your doubts in the comment section. Thanks for watching. That's all for now.